the Sustainability Management Master's Program, you're answering one simple question. Do you care about your future generation? If you care about your kids, their grandkids, then you care about sustainability. And a sustainability manager is someone who has the tools to make people understand how they can contribute towards developing a sustainable world. We have both part-time and full-time students. Our curriculum is 30 hours. Instead of thesis, we have a research project course and a seminar course which provides them with the kind of research background they will need to be successful in their job. But at the same time, sustainability is not always everything about environment. It also relates to the business. They will take a sustainable business strategies course. They will take a project management course. Most of these courses are going to be taught by industry people, the people who are doing sustainability on a daily basis as a part of their job. Any organization that has a large number of employees and has a physical infrastructure, they will have to have a sustainability office. If you have the passion to develop and maintain a sustainable world, come to us and we will help you shape your passion into a career which will create an impact.
The Stevens Institute of Technology is proud to present the Hugo Nu and Geocentric Consultants Hugo Nu Corporation Sustainability Seminar Series, co-sponsored by Brown and Caldwell, H2M Architect and Engineers, BEM Systems, Catalyst Group, and WSP.
Hey, we're a familiar group. It's good to be with everybody here, and congratulate you guys to getting to this point in the semester. I'm excited to have our fellow my panelists who are huge in their own realms, and the ability to work with them. You're going to hear more about that, but I really found having a background, it's not in my bio, but I did help to develop EPA's environmental justice program many years ago and created the Mid-Atlantic program, and have integrated, just like the principles of sustainability, integrating the principles of fairness, equity, recognizing the importance of who's there, different cultures, how you communicate, to be effective in engaging our communities and creating that balance of sustainability has always been important. So I thought, before introducing our speakers, and we're going to switch, Dr. Koran before Chris Whitehead, who's done some real interesting studies. I wanted to give a bit of context on why this is an important topic. We've heard about environmental justice, we've heard about social justice, we've heard about climate and impact on overburdened frontline communities. And certainly we've heard the messaging from DC about this buy-infrastructure legislative money that's coming through, across a variety of really sectors, departments, everywhere from EPA, water, brownfield, Superfund, to DOE, energy, HUD, you name it. And so it is exciting, but let's take stock of where we are and how we, as we say, enable the weakest link. We're not going to be sustainable, and how do we bring some justice into this arena? So I thought I'd just briefly visit with you kind of where we are, and then turn it over to our panelists. All right. So you likely, I'm sure you guys have seen the latest climate report from NOAA. There's also information that our own New Jersey Department of Environment has collaborated on with, I'm sure, Stevens and Rutgers and others, but we are way behind. That there's a century's worth of sea rise in just 3 decades. We already know precipitation is already 2.5 to 10% higher. It's increasing significantly every year. And we of course know that as oceans warms, because we'll talk about greenhouse gases, but how that relates to these types of extreme events, whether it's flooding on the East Coast, fires and hurricanes. I grew up in South Louisiana. We're in hurricane season earlier as we speak. More tornadoes. It's worse, right? We're in a climate crisis. The four takeaways of that report looked at the next 30 years of sea rise, on average 10 to 12 inches in the next 30 years. As I say, 2030 is today. This is not like a spontaneous reaction. 2030 is today. So decisions we're making today is about 2030 and beyond. More damaging flooding, emissions, of course, have everything to do with that. As we see warming seas, we see more of these kinds of weather events, and we need to get continued tracking. And of course, as we all know, those who are most disadvantaged are the biggest victims. They're also have the smallest footprint, by the way. They're not the biggest consumers, but they inherit and they impact. This is from Katrina, and I had to deal, live this through with family being displaced, and really horrors, actually. But this is the world now. So let's talk about this clean energy economy. Was really fast growing before COVID hit, slowed down a bit, but it's starting to ramp up again, I think, in this country and beyond. And I recall when being in the environmental field, when we talked about the promise of solar, we were going to employ everybody. It's exactly the way we're talking about this today. Is disadvantaged communities, great jobs. By the way, solar pays on average significantly more than most other jobs. It's ramping up again. And we've talked about the promise, for not only reducing those environmental pollutant burdens, greenhouse gases, air emissions, and other impacts in low-income communities, but also, the promise of jobs. However, here's a latest report from E2 Environmental Entrepreneurs, along with other organizations around the country who took stock in this particular report on assessing the status, the demographics of who holds these jobs. And there's a big problem here. Essentially, the study points out that, and I'm just going to summarize this, and I'm going to get into the next view. But I think this is important because we continue to say, oh no, everybody's included. We're going to bring solar. We're going to these low-income communities. And I'm not only talking about urban communities, but rural communities who, in fact, depended upon coal. We're going to reduce the environmental impact. We're going to increase jobs. Black workers represent 8% of the clean energy labor workforce, compared with about 13% of the nation's total workforce. Hispanic, Latino workers, nearly 17% of the clean energy workforce. Racial and ethnic minorities account for nearly 4 in 10 of energy workers. About 8% of clean workers are Asian, slightly higher than their presence in the national workforce, while Pacific Islanders and Alaska and other Native Americans make up 1% of the clean energy workforce. Women hold about 27% of all clean energy jobs, compared with women in the general workforce being about 48%. Renewable energy, however, employs the highest share of Hispanic or Latino workers in the US energy sector. Black, Asian, Indigenous, multiracial workers account for 27%. So I just wanted to give that context, where we are, and lead this off by introducing our first speaker to talk about what he's doing lately. I know when I met Dr. Koran, he said he talked about a lot of his groundbreaking work, and certainly in solar. And I remember driving around Princeton. I lived in Princeton at one time, still close by, and seeing these solar panels on all of the streetlights. And for those of us that live or work in New Jersey, you know what I'm talking about. And I remember thinking, because I'd worked on green streets with EPA, thinking, wow, what a great idea. Well, here's your guy, that did that, which was so cool. And, I'm excited about the next venture with him. He's an investor because we're doing some things at Carney Point. Investor, clean tech entrepreneur, seasoned executive in the semiconductor, power, and clean tech sectors. He founded Power Edison and more recently EV Edison, leading these companies in innovative mobile battery storage solutions for the grid and high-powered electric vehicle charging solutions and fast charging mobile infrastructure for EVs. I can go on, but I know he would prefer that he get started with his conversation. But I also think that this mobile infrastructure, which can leapfrog, and that's what we need right now in terms of getting us moving in this new EV renewable economy, is very important. So with that, I'm excited to turn this over to Dr. Koran.
Thank you, Dom, and thank you, Dr. Sarkar and Samir, for having me back again at your seminars, and always a pleasure. Can you see my screen?
Yes.
Yes.
Very good. So like Dom mentioned, I'll be speaking about, actually we have two sister companies, Power Edison and EV Edison. I look at a side screen when I look this way. And I want to share with you some of the innovative projects, innovative technologies we're working on, the jobs, the type of jobs that can be created and we are creating, the impact on environmental justice communities, and why we believe this work is critical and it's timely as we help with the energy transition as a whole, and as we help, for example, in New Jersey, help meet the state clean energy goals. What I have here is a snapshot of some of the solutions that we are building that are innovative, that are rich with technology content. And primarily, they're broken into two areas. One, under Power Edison, we have developed and engineered solutions that are mobile in nature. And in particular, we have what we call mobile energy storage. These are systems that act as microgrids or act as batteries that can be moved from one area to the other. They can be, frankly, on trucks. They can be on the water, on barges. They can be on other modes of transportation. And they perform no less than 20 functions on the grid. And at a previous seminar that you hosted me at, I spoke at length in terms of what these applications are in terms of the energy storage one. So I won't go through all of them, but I might highlight some of these areas and how energy storage is coming to the rescue, especially in the area that we're operating today. Energy storage is referred to as the holy grail in the power sector today because it complements solar, so the solar can be offered 24/7. The same thing with wind. But frankly, there are many other applications, things like what we call T&D deferral, effectively shoring up the grid sooner than the time and the budget and the effort that it takes to rebuild the grid. And we're seeing that also energy storage can be critical at a certain time of the year. By making it mobile, it allows us to deploy storage when needed and where needed, rather than have an expensive development and an asset sitting year-round at a location when the need is only there for, say, the summer peak. There are specific needs, say, in New York and New Jersey, where we currently reside. For example, in New York City, there's significant need for energy storage on the grid. Land is expensive, as you know, so by putting batteries on barges, we have engineered and developed barge solutions that allows us to deploy large-scale batteries. Instead of on land, it's on the water. But also by being mobile, in this case on the water, that acts as a microgrid that can be dispatched to critical loads, either in the form of emergencies or these loads that might have seasonal requirement. Like I said earlier, it could be a summer peak, a winter peak, it could be 2 or 3 or more locations throughout the life of the asset. And from a financial perspective, when the asset is mobile, it's easier to finance, because if the project economics go away, not an issue, you can repossess that asset and move it. The same is true when we put them on trucks or on the road. There are just numerous and varied needs for energy storage on the grid that allows us or our business partners to deploy them effectively. And I will share with you some graphics and images, some of these applications. So today at Power Edison, we were proud to say that about a year ago, we got contracted to build the world's largest mobile storage system on trucks. It happens to be a fleet of batteries and associated switchgear and transformers and inverters and so on, that is purchased by a utility in the Midwest, and the utility would use those assets to strengthen the grid, to respond to grid needs, to support the growth of renewables, to support the growth of EV infrastructure. I did include a snapshot here of how mobile batteries can help with EV charging, and why would batteries be associated with EV charging? It's actually a very strong nexus between batteries and the EV market. One of the key applications for mobile batteries associated with EV charging is that we see today many entities, whether schools, whether municipalities, whether rideshare companies, or just the public in general, that is procuring EVs at a high rate. That is growing faster than the ability for the power companies to upgrade the grid and provide power where it's needed. And frankly, sometimes it's something that comes up at the 11th hour. Someone commits to buying buses or refuse trucks or any large electric load for mobility, and then they find out that it's going to take 2 to 4 years for the utility to bring new power lines and deal with eminent domain issues and bring that power. So by having mobile batteries on, say, trucks, those can be shuttled daily. You can charge them up at a nearby substation, at a nearby power plant, at a nearby point where you have access to power, and you can bring it to the site where the EV charging is required. So we find that to be really a great application. And actually, that is why Power Edison has been around for over 6 years. That's why we launched a new company called EV Edison, focused on the EV charging application. So these are two sister companies, Power Edison and EV Edison. One is focused on the battery content, and one is focused on the EV applications themselves. So, like I said, batteries can address almost 20 applications on the grid. However, EV charging support happens to be a major one. And for that reason, we created a new company called EV Edison. I'll talk more about EV Edison. One of the things that I wanted to share with you is that Bloomberg New Energy Finance published recent data that by Q1 of 2022, the combined investment in electric mobility, that's kind of EVs and the infrastructure around them, had exceeded the combined investment in solar and wind. And depending on how you analyze the data, different views, different times, but as a general theme, that electric mobility not only caught up with the solar and wind renewable sectors, but kind of almost the size of the two combined. That's a significant growth. And if you look around you in your neighborhood, you see people buying EVs, people installing EV chargers. You could see why those numbers make sense. People are spending a lot more on EVs nowadays, and that's why it's catching up to the solar and the wind industry. EV Edison is also, as a company, we're excited to say that we have a joint venture with Hugo Nu, where Dom is, and we're very excited about that. And we have a joint project together. Hugo Nu is the owner of a 130-acre site in South Kearney, a site that has amazing history in our local history here in terms of industry, in terms of transportation, in terms of actually historical significance with World War II and so on, and with the naval industry. And we joint ventured to help in so many ways address the greenhouse gas issues that exist in the Kearney and surrounding areas. So we are committing serious acreage on site, and we're bringing significant power to the site where we are going to use that power to be deployed for EV charging. And in particular, we're focused on what we call medium and heavy duty traffic. That's the site is about 10 minutes from Newark Airport, 10 minutes from Port Newark, which is the largest port on the East Coast. It's also 10 minutes from the Holland Tunnel. There's significant traffic, especially medium and heavy duty trucks, that are very polluting today. As we know, the backup traffic at the port, the traffic going back and forth. So by being able to deploy a large charging hub, and it's in fact it's so large that based on public information from what we see today, it is by far the largest, would be the largest in the country in terms of providing EV charging infrastructure. So that's public information. We have, there's some media coverage about this, and happy to answer or address more questions, and Dom can do the same. We feel this is a critical project also from an environmental justice perspective, because when you look at people who live in and around Kearney, Harrison, Newark, they are disproportionately affected in a negative way, frankly, with the greenhouse gas emissions. You look at the asthma rate, you look at the air quality, you look at the pollution. So to us, it's a worthy cause. To us, it's critical. To us, it makes economic sense to be right where the heavy load is, but at the same time, environmentally, it's a critical step in the right direction. Just sharing some images. These are various images of how heavy-duty chargers that would be needed for truck charging look like. This is not necessarily exactly what we might build here or there, but I wanted to say that it's meant for the more difficult problem to solve today. These are not the small chargers. These are hundreds of kilowatts up to a megawatt and more in charging power. I've included some additional images to how the barge solutions would look like, and they can be transported from one location to the other, or the mobile batteries on trucks that can be dispatched and deployed to areas of need. So back to you, Samir, if happy to address or answer questions now or at the end of the presentation.
I'll leave that up to Dom.
Yeah, so does anybody, I know that Shahab may have to leave at 6, so if you've got questions based on what you heard, we're going to give some time. So does anybody want to raise a hand or put something in the chat box? Because I'll start asking questions if you guys don't. I'll ask a question. So Shahab, you know, this is exciting, obviously emerging, evolving. You mentioned that there were batteries can address almost 20 applications on the grid. And you, of course, just talked about fast charging infrastructure. Can you share some of those other applications?
Sure. So we break those applications into 3 main areas. One is what we call the in front of the meter or the wholesale revenues. and I'll talk a little bit in detail about those. The second area is what we call the reliability applications. That's kind of these are the functions that your utility would perform. That's in our area would be Con Edison or PSE&G. And then the third set of applications is what we call behind the meter applications. Those are the ones where a homeowner or a building or a factory would be performing. An example of in front of the meter applications for energy storage on the grid is something called spinning reserve, something called non-spin reserve. These are effectively standby, equivalent to standby engines or rotating engines that are spinning that you can call upon for various support of the grid, whether it's power, whether it's energy, whether it's frequency support. There's another application called capacity. Just again, it's a form of standby power that you can call upon. There's something called black start. If the grid goes down and you need power pushed back into the grid, these batteries can perform that. There's something called frequency regulation. The grid is an AC signal, so it's kind of alternating at 60 hertz, 60 times a second in the US, 50 times in Europe, for example, and the battery can perform that function. It's almost like steadying the clock, if you wish, on the grid. These are in front of the meter applications. Applications associated with reliability and what the utility or the delivery company would do, things like transmission and distribution deferral. So what is that? That's where, let's say, a neighborhood has significant growth of power load beyond the feeder capacity, beyond the capacity of the utility to bring that power to that neighborhood. Sometimes those neighborhoods reach that level and exceed the load, exceed the feeder capacity, say in the summer only when air conditioning is running. And so what you can do, you can dispatch those batteries. They charge at night when the air conditioning systems are not running. They charge at night and then they discharge when the peak happens. And you can park them, if you wish, for a month or two during the summer in that neighborhood. You allow the utility to defer the investment and the upgrade in that feeder or transmission or distribution line or substation. That T&D deferral is a key reliability investment and application. Now, why do we call it reliability? Because really not about price. If the load is beyond the feeder capacity, the voltage is going to drop, the grid collapses. So it's whether you have power or you don't have power. It's not about how much the energy is going to cost you. And then if we move to the third set of applications behind the meter, one of them is backup power, having your own backup power at your home, at your factory or office. Another application is what we call demand charge reduction. If you are a commercial or industrial customer, the cost of electricity and the cost of power to you is not simply how many kilowatt hours you're consuming, it's how many you're consuming in addition to the rate at which you're consuming it. So if you spike at a certain time of the day, you will get a multiplier on your bill at the end of the month. And so having a battery on standby can reduce those peaks or those spikes and help you maintain a more manageable electric bill. Then there's something called self-consumption. You might have more solar than you need during the day, but you need it at night. So if you have a battery, you can charge it from the excess solar energy, use it at night. So again, I'm giving you a flavor of some of these applications that exist on the grid, depending who the owner or you can be behind the meter, you can be the utility, or you can be on the generation and the wholesale side.
I know we have to move on, but I have to ask this question because you talked about the grid, and we know the grid is still not predominantly renewable. And you compared battery growth, to solar and wind, which are renewables. So could you, just point out how batteries are renewable or greener, even while relying on, as we try to, ramp up on renewables on the grid?
That's a good question. When you look at the grid today, the grid is designed for the peak consumption because electrons, we don't slow them down. We don't, if you have traffic, you can have backup traffic, say, entering the tunnel at New York City. You can't do the same with electrons. Electrons are just in time produced for the consumption. And batteries can become a buffer, which, like I said, the grid today doesn't really have an electronic buffer. They have buffer in the form where you have liquid fuels or gas that gets burned and generates electricity. As we know, solar and wind is not a dispatchable asset. You can't say, I want solar at night or when you need it. So why are the batteries classified typically as a renewable source? Because they do primarily help renewable energy, and I'll explain. So for example, when you need dispatchable power, typically you turn to a fossil source. I mean, some hydro, but hydro is not as prevalent as fossil. So some turbine, some generator somewhere based on fossil fuel, is fired up to provide that dispatchable power. You can't call on a solar panel to give you extra power or wind when you need it. A battery allows you to store that renewable energy and becomes a dispatchable source of that clean energy. So allows you to turn off and reduce the reliance on those fossil peakers and bring more of those renewable energy sources in a dispatchable way, which is what's missing today from solar and from wind.
Great, thanks. Thank you.
Hey, Dom, if I may ask one question before Chris takes over. Shihab, can you give us a couple of specific examples of how, these are tied with creating opportunities for EJ communities?
Sure. So I'll go back, our joint project with Hugo Nu in South Kearney, we are working with the governor's re-entry program run by Governor McGreevey, where he, along with Wendy Nu, who is the owner of Hugo Nu, they are training people through the re-entry program. We're working with them to get them trained on the specific technologies and solutions. And just to give you a simple example, we are in the process of building and deploying mobile batteries, and those batteries need to be driven around and they need to be dispatched, and there's software and there's hardware and there's connectivity and there's electronics and there's electrical connections. So all these are unique and new skill sets that are required for the build out and the deployment. The same thing with the EV charging. And we are engaged with the local community for training. We're engaged with the local community to create those jobs. And it also makes common sense because we're building that in those communities. So it just makes just good business sense as well to hire from the local community and to create the jobs with the community that we are serving and working with.
All right, thank you. Dom?
Okay, thank you. So we're going to move on to Chris Whitehead. So I know Chris has some slides to share, and maybe in the interest of time, I won't go back to my slides, Chris, if you want to just put yours up while I introduce you. Chris Whitehead is the creator of the Alliance Project, a multi-phase survey study that examines potential environmental impacts from large infrastructure projects in environmental justice areas and compares the perspectives from multiple stakeholder groups. The project represents a range of community engagement options, from traditional minimum mandates to a new adaptive engagement model that tailors outreach to each community and argues for the immense benefits of the latter. So very, very community, very place-based, certainly the way to go. And I'm sure it's a continuing learning curve in terms of how to improve the way we not only engage communities and solve problems, but how communities are empowered to solve problems and take care of their own assets. So I was real excited when I saw Chris's study. Anxious to hear about it. With that, Chris, I'll turn it over to you.
Well, thank you very much, Don, for that introduction. And can you just also confirm quickly they actually see my slide deck?
Oh,
Yes, we can.
Thank you. So just to give a bit of background, I've been an environmental consultant for about 15 years or so, give or take, specializing mostly in air compliance work, largely for industrial clients, power plants, chemical, all across the board. But over the last couple of years, I've done a lot more environmental justice work, especially associated with the New Jersey environmental justice law that was first passed in 2020 and basically regarded across the board as the gold standard for a state EJ law. And it's been actually checked in on numerous times by other states who have kind of cherry picked from that and brought things over to their own state. But I digress quickly. I also have an MS in environmental management, bachelor's in poli-sci, and a sustainability management certificate from MIT. So these topics are very, very important to me. And I wanted to try to develop a path where I could find impactful work in these areas. And I was given an opportunity last year to write for LexisNexis on any topic I chose. So I was, okay, what do I know pretty well and what can I do to try and be impactful? So I decided to look at the intersection of offshore wind and environmental justice. And I decided to do a study and bring in stakeholders from the legal, consulting, developer, and environmental justice and stakeholder groups and ask them what their opinion is of these projects. Where exactly do they think the environmental impacts are going to occur? And what is reasonable to ask of developers to mitigate these impacts and minimize them whenever possible? And then also, as we went further through this, the discussion ended up being much more about how we do community engagement and how it's absolutely vital to move away from the historical models of essentially just checking a box and getting it done with and going on with your project to a more adaptive engagement model where you actually tailor your outreach program to each town or city that you're going into, understand what their capabilities are, and move forward and judge the status of your outreach program. If it's not going well, adapt to it and tinker things here, there, and actually try and follow through on everything you're trying to promise these areas from these projects. Overall, I'll go through exactly, I have a number of slides here. I know we're a bit tight on time, so I'm not going to spend too much time on each. But everyone I spoke to who ended up doing a survey had an average experience in offshore wind of approximately 4 years, which is about what you would expect, because that's how it's been taken off during that time period. Again, I drafted all the questions myself and tried to do it as much as an environmental impact study as I could. I have experience actually running Mayflower Wind and did the air project for their COP submittal, which is the first major step in how these commercial offshore wind projects get the okay to go from the Bureau of Ocean Energy Management, or BOEM. And once they get that okay, they can then start construction and actually move on with the project. this is a quick breakdown of the contacts I targeted and the actual survey results for what I was able to get from the study. Overall, 34% response rate is incredibly high. But a couple things you'll notice here, there's a good chunk who were only comfortable talking to me about the topics and didn't want to actually submit a survey for various reasons. But there's also one segment, legal, who didn't want to talk about the issue at all unless they were submitting a survey. Of course, there are some obvious reasons on that. If you look at the far right-hand column, the one group where I didn't get the type of response rate that I was hoping for is the environmental justice or community groups. I'd like to go into why I found out that was. Some of the things I heard back, we're very interested in these topics, but we just don't have the bandwidth right now to take on a project. Or we don't have the training on this to comment on technical topics. Our members are interested in it, but we have to have a little bit of help to train them on. One of the most striking comments, though, that I got was the fourth bullet here, that they were looking for partnerships, not extractive one-off information requests. And this is the 20th one that I got. There are a lot of people out there, a lot of firms, developers, various OEMs trying to get comments from the exact same people in stakeholder groups and contacting the exact same people who might not have the bandwidth to comment back. We have to think of ways to give them the training and to actually bring down the impediments for them to comment and make it easier for them, and also be fair. It's not actually realistic to ask one person to comment on these things 22 times. There has to be a better way. And we're going to some of the things we're going to actually propose for how to do that. Why is it so important? And this table is an excerpt from work I did with EPA late last year. If you know a little bit of background on this, each state defines overburdened communities based on socioeconomic data, combinations of factors like the ones you have up on the screen here. Each state's a little different in the exact factors they choose and the exact threshold for each factor. But it only takes oftentimes one of these to start the process and be an overburdened community. And as you see, along the coasts in this country, it is a huge issue. So the first question we addressed, how many ports is the average project going to use? And the vast majority responded over 0 to 3. That's important because if it's in different states, you're going to oftentimes have to understand different compliance programs. That's where this whole trend is going. And you're going to have to also interact with multiple communities. So there's a lot being asked of developers and on the flip side, environmental justice communities as well. What factors go into actually deciding a project? This isn't going to surprise you. The ones tied to actual logistics, the physical characteristics of the port itself were ones that came in first. Other secondary characteristics like workforce availability and support in the area came in after that, largely because, and we found this out in pre-form answers, that that everyone involved thought that the other factors could be worked on and could be supported. Where if you found a port that you wanted to use, if you put the time and investment in, the other factors would fall into place. Impacts from these projects. This is one of the most critical slides, in my opinion. And again, I chose these answers, I'm sorry, potential answers, just from what I would call the average offshore wind project and the types of operations that would be going on around a port at any given time during the 2 or 3 year construction phase. And the top answers here were associated with increased traffic and construction emissions on site, as well as noise. Not terribly surprising, but kind of interesting in that if you look just on an actual emissions perspective, the lion's share of these actually come from the vessels. But vessel emissions was much further down on the actual list itself. Let's see, going through here. I thought this was interesting. What extent should the developer go to actually try to minimize impacts? And what we found out is that the developer wants the community involved more. They want to actually be involved at the level of discussion and mitigation plans, which isn't a requirement at this time. I know we're a little time to time, so I'm going to keep going. Potential hindrances to community engagement. This is very interesting, and I obviously read the slide here, but I would focus actually on the third one called NIMBYism, which is actually an acronym for Not in My Backyard. You found this from people within environmental justice areas and from people without. In environmental justice areas, they didn't want in the backyard for concerns of potential vehicle emissions or potential health impacts from increased activities. Although overall, a lot of these projects are only happening because environmental justice groups fought for them for the long-term benefits. But there are still some concerns on how to mitigate the impacts during construction. But on the flip side, you have richer communities, oftentimes who have nice houses on coastlines, just as an example, who don't want the turbine back messing up their views. So it's a little bit of an interesting thing that we found the same answer from two sides. Economic benefits, by far way the answer was jobs. Environmental justice is, you don't immediately equate it as an economic issue, but it is, because these projects have immediate health impacts and extended ones over time, of course. But there's also a lot of promise for jobs for the people who desperately need them. And what exactly is being done to keep those jobs within the community and actually train up the local job workforce to be able to take those jobs and not have them outsourced at the time. Because hypothetically, if a developer has to fill 100 jobs and there's no capability to do that locally, they bring them those jobs in from elsewhere. And I think we all understand currently that it's a tight workforce. A lot of companies can't find people now. What's going to happen fast forward 5 years, 10 years as these large projects come online, more opportunity, but pulling from a lot of the same buckets of jobs. I'm sorry, same buckets of potential employees. It's a concern, and it's only going to be remedied through increased training opportunities. I'll just get through this very, very fast, but we also talk about what mitigation measures are appropriate. And these follow along the lines of also the impacts we discussed earlier associated with trucks and construction dust mostly, and also moving toward electric vehicles as opposed to fossil. Dominic touched on this briefly, but we also spinning this into the second phase of the project, focusing more now on collaboration issues and ways to bring down impediments to stakeholder engagement. And ideally, the goal here is to get more surveys turned in on our website, and the link here is below. And if we get a big enough pool, I want to anonymously compare each subgroup against each other and find out how legal feels against developers on these issues. And I've gotten a lot of interest from a couple of utility boards and hopefully help them guide some public policy on this. That's one of the goals of this extended project. Hopefully be able to do by the end of this year. Touch on all these, I'm gonna skip over that and just acknowledge the participants in the project itself or people who contributed to it. And I think, Dom, with that, I could turn it back over to you if we have any questions.